Hello everyone, welcome back to your online classes. I hope you all will be fine and have completed your holiday homework. Students, this is our first video after your summer break. In our previous videos, we have completed lesson number 1 and lesson number 2. So today in this video, we are going to start lesson number 3rd. Okay, so let's begin our class.
Lesson number 3rd is energy. First we will see what is work. Work is said to be done when a force acts on an object and the object is displaced in the direction of force. Okay, so what is work? Work is said to be done when we apply a force on any object. Suppose this is a box, and if you apply a force from left to right direction, okay, and this box moves from left to right, okay, and that is the direction of force because we are applying the force in the direction from left to right. And if this box moves towards right, that is in the direction of force, then work is said to be done. Okay, so what is work done? Work is said to be done when a force acts on an object and the object is displaced in the direction of force. Okay, the work done on an object is a product of the force applied and the displacement. Suppose this is a box, and if you apply a force F on this box and it covers and moves here, and the displacement covered is S, we denote displacement by S. Okay, so the formula for work done will be W is equals to F. F is the force that we applied on this box and S is the displacement, okay, of this box. So we get the formula W is equals to F into S. Okay, work done is equals to force into displacement. The unit of work is joule. If F is 1 Newton and the displacement is 1 meter, means suppose if we apply a force of 1 Newton on any object and the displacement by it is 1 meter, then the work done is 1 Newton meter, or we can say 1 joule. That is 1 Newton meter is equals to 1 joule. So 1 joule is the amount of work done when a force of 1 Newton displaces an object by 1 meter. Okay, what is 1 joule? 1 joule is the amount of work done when a force of 1 Newton displaces an object by 1 meter. Means when we apply a force of 1 Newton, it displaces the object by 1 meter. That is known as 1 joule. Then the amount of work done is 1 joule. For example, if 5 Newton acts, if a force of 5 Newton acts on an object is displaced by through 2 meter in the direction of force, then the work done will be force into displacement. So if the force is 5 Newton and the displacement is 2 meter. So according to this formula, force into displacement 5 into 2, that is 10 Newton meter or 10 joule is the work done. Okay. Now energy. What is energy? Energy is the capacity to do work. What is energy? Energy of an object is its capacity for doing work, or you can simply say that energy is the capacity to do work. The unit of energy is the same as that of work, that is joule. Okay, 1 joule is the energy required to do 1 joule of work. 1000 joule is equals to 1 kilojoule. There are different forms of energy: heat energy, electrical energy, chemical energy, mechanical energy, potential energy, kinetic energy. These are the potential energy and kinetic energy are the forms of mechanical energy. So these are the different forms of energy. So now we will discuss about them. First one is mechanical energy. What is mechanical energy? Mechanical energy is the energy that an object has due to its motion or position. The energy that an object has due to its motion and position, that is known as mechanical energy. Mechanical energy encompasses two types of energy, that is potential energy and kinetic energy. So potential energy is the energy due to position, and it is also known as stored up energy. Energy that is not causing changes now but could cause change. Means the energy that is not causing any change right now, but it can cause a change because of the stored up energy of that particular object, that is known as potential energy. Now kinetic energy is the energy of motion. So this energy is due to motion. Suppose a body is moving, is in the state of motion, so it possesses kinetic energy. Okay, so these are the forms of mechanical energy. Second one is heat energy. Heat or thermal energy is how hot or a cold an object is. Heat energy is what? It is the energy which tells us how hot or cold an object is. Heat energy is transferred from warmer objects to colder objects. Means heat always flows from warmer objects to colder objects, or we can say that heat always flows from higher temperature to lower temperature, because the temperature of warmer objects is more as compared to the colder objects. So heat always transferred from the higher temperature to lower temperature. Heat energy can be produced from other forms of energy. Means other forms of energy also produces heat energy. For example, if you touch a glowing bulb, okay, so it has electrical energy, but if you touch it, you will feel hot, okay, because that electrical energy is converted into heat energy. Okay, so other forms of energy also produces heat energy. The temperature of an object is related to how much thermal energy that an object has. Means the temperature of an object is related how much thermal energy or the heat energy that object has. Okay, now next one is light energy. Light energy is a type of wave energy which can be sensed by the eyes. Okay, means we can sense it by our eyes. We can see light energy. Other types of energy can produce light energy. Light energy produced by sun is called solar energy. Light energy always travel away from its source. Okay, so you can see here sun is here. So the rays from the sun is going away from the source. Here the source is sun, and the light rays, the rays of sun moves away from it. So the light energy travels away from its source. Okay, and it always travels in a straight line. Light energy always travels in a straight line path. Okay. Next one is chemical energy. The energy possessed by fuels such as coal, oil, gas, etc. is called chemical energy. The energy possessed by the fuels such as coal, oil, gas, petrol, diesel. Okay, these are the this is known as chemical energy. The chemical energy of petrol or diesel is capable to move a car or a truck. Because of this chemical energy of petrol and diesel, is capable of moving car or truck. The food that we eat possesses chemical energy and makes us do work. Means this, the food that we eat, it has chemical energy and it provides energy to us so that we can perform our day-to-day task. Okay, so that we can do our work. Okay, so this is chemical energy. Next one is electrical energy. Electrical energy comes from the movement of charged particles such as electrons. Electrical energy is the movement of charged particles such as electrons. Electrical energy is also referred to as electricity. Machines can change electricity into other forms of energy like heat, light, sound, or mechanical energy. Means machines can change electricity or the electrical energy into many other forms of energy. For example, heat, light, sound, or mechanical energy. Electricity travels through conducting materials such as wires. This electrical energy travels with the help of conducting materials that are known as conductors. Okay, so they travel through wires. Electrical energy can be changed into other kinds of energy, means electrical energy can be changed into other kinds of energy. For running a motor, electrical energy is used and is changed into mechanical energy. Okay, so this is the example of electrical energy. Okay, sound energy. Sound energy is the energy of sound waves as they travel. So the energy that sound waves with which the sound waves travel is known as sound energy. Sound is created by the vibrations of an object. Means this is due to the vibration of any particular object that we hear sound. So sound is produced by the vibrations of an object. The speed of the sound depends on what the wave is traveling through. Means uh, the speed of the sound depends on the medium through which the sound wave is traveling. Okay, because the speed of sound vary from medium to medium, means the speed of sound in air is different from the speed of sound in water. As water and air we are comparing here are the two mediums, so the speed of the sound depends upon the medium through which the sound wave is traveling. The sound travels more quickly through a solid than through a liquid or through air. Okay, so the speed of sound is different in solid and liquid and also in air, and the speed of sound is more through solid as compared to liquid or air. The sound waves cannot travel through a vacuum such as outer space because there is nothing there for the waves to travel through. As I told you that sound always requires a medium to travel, and if there is any vacuum means where there is no air. Okay, as example is outer space. In space there is no air, so we cannot hear sound there because sound always need a medium to travel through, and due to that medium only we can hear sound. When the sound waves travel through the medium and is reached to our ears, then only we can hear the sound. So sound waves cannot travel through a vacuum such as outer space because there is nothing there for the waves to travel through and we cannot hear the sound there. Okay, now next one is nuclear energy. Nuclear energy or atomic energy is the energy that is released spontaneously or artificially in nuclear reaction. What is nuclear energy? Is the energy that is spontaneously or artificially released in nuclear reactions. Okay. The main feature of this type of energy is a high amount of energy which can be produced per unit mass of material used as fuel. Means the amount of energy that is being released in nuclear energy is very high. Okay, which can be produced per unit mass of material used as a fuel. Means the amount of energy released per unit mass is very high in nuclear reactions. Okay, so this is nuclear energy. So these are the different forms of energy that we discussed in this video. Now what you have to do, you have to read the lesson. All these forms of energy you have to read from your lesson, and this is your homework. Okay, so this is all for today's video. Thank you.